Welcome back, Matt 2. Today we're going to just be continuing our talks about proportions and proportionality. You're going to be encountering a lot of proportional triangles and stuff in the next couple days. And I want to make sure you know about a couple more theorems so you know what pieces are proportional to one another. So you should have some blanks to fill in on your notes. So the first one is going to be called the side splitter theorem, which has to do with triangles getting split, or their sides getting split. So if a line is parallel to one side of a triangle and intersects or splits the other two sides, then it divides those two sides proportionally. Okay, so basically what's happening here in our diagram down here, we have this triangle. It's the big one on the outside. And it's getting split by this line, which is parallel to the bottom side of the triangle. Okay. And when that happens, we are cutting the two other sides of the triangle proportionally. So that means that x is proportional to 12 in the same way that 10 is proportional to 24. So when I set up my proportion, again, there's no real wrong way to set up proportions as long as you have matching going two ways. But most people do is they just kind of treat this line in the middle here like the fraction bar. And we would say, okay, 24 over 10 is proportional or equal to 12 over x. And from there, we can cross multiply. Okay. So I'm going to have 24 times x, or 24x, equals 10 times 12, which is 120. And if I divide by 24, pretty sure I would get 5. I get that x equals 5. Okay. So this little side down here is actually only 5. Okay. This also happens in another situation. Okay. Which is our corollary to the side splitter. So in math, a corollary is like, oh, by the way, because this thing is true, this other thing is also true. Like, it's just a little nugget of truth added on at the end. Okay? So if 3 or more parallel lines intersect two transversals, then they divide the transversals proportionally. Okay? So here, these are my 3 parallel lines. And the other 2 lines going through them are called transversals. If you remember last year, we spent a lot of time going over the different types of angles that are created when we have parallel lines and transversals. They also happen to divide the transversals proportionally. And again, I can set up my proportion kind of visually, treating this middle line like the fraction bar, and I'm just putting an equal sign in here. So I can say, okay, 2 over 8 equals x over 12. And I'm going to go ahead and cross multiply. So 2 times 12 is 24, and 8 times x is 8x. If I divide by 8, I will get that x equals 3, or my missing piece here is 3.